Okay, so we left it back here, right? Yes, so we're talking about the agent doing these. So what I want to check first is, to be honest, what has it done? Because it's just, I think it's just that at this point there's so much in here. That's kind of one of the downsides, right? Like if you kind of quickly lose oversight of what's going on. Give me a rundown to what is currently built and how can I run the initialization script test scripts. Okay. I'm sure this just too much mess. So maybe I should also ask you to just clean up a little bit. And that's definitely one thing to do. Okay, so what is it? So it says so currently build a small model configuration, small config, smaller transformer model, 300k parameters. It says 28 million. Reduce vocabulary size, 2000. Do we need to reduce the vocabulary size though? Do we really need to reduce the vocab size for the small network? Smaller dimensions, initialization test scripts, minimal, quick init test, complex test framework with multiple initialization methods, quick test. I think this has become a huge spaghetti crap. Weight initialization methods, normal distribution, Xavier Glory initialization, heat initialization. So these are different techniques. Lican, orthogonal initialization, how to run initialization tests. You didn't reduce the count size for the solar network. The main reason we reduce the count size to decrease the total parameter count. Since the embedding and output layers, okay, do they depend on the vocabulary size? Yeah, well, of course, because you need to encode. You need to encode embedding layer. So, wait, this something just makes no sense here. So the embedding layer is the vocabulary size times the model parameters. That's the depth, yeah. But it shouldn't be counted as part of the parameters, right? The embedding layer. Wait, we're not. This makes no sense. So the embedding layer shouldn't count as part of the parameters because we're not modifying it during the training process. Rock. So what typically counts as parameters in AI models, LLM models? So those are not trainable parameters, right? We're not training the embedding layer, are we? Or am I just being stupid? So the internal variables, yeah, or weights, the model, exactly, it's just the weights, right? Define the model's behavior, exactly. Wait, no, the weight, biases, embeddings. Oh, they do actually are also parameters. Oh, okay. Token embeddings, mappings of words, or subwords to vectors, and positional embeddings. Are they? Oh, okay. I didn't know that. Let's roll this back stuff. Let's roll it back here. Okay, so it's all good. It's all good. So what is it saying? So output layer, transformer blocks. Yeah, across all blocks. Let's roll back here, but what I want to do is let's roll back here, roll back. Really? I didn't know that. Okay. Okay, but I want to keep the vocabulary size. Because I want to keep I want to keep these being as expressive as possible, but maybe we don't need 200, like we don't need like 256 to express a token. So we can just go small. Okay, so can you please modify the current smaller setup to have to keep the original 50,000 vocab size. Reduce the size of the other parameters, weights, but keep vocab size the same, and let's aim at doing let's aim at doing something around 100k total parameters. 100k. We can still let's it's okay. Let's just do something like this. So what's the vocab size of nano GPT from Kapata? I understood nano GPT does quite well with the Shakespeare model, with the Shakespeare dataset, but it's only 100k parameters. Okay. So I'm going to ask it to okay, that's good. So that's too small. What does it say? So oh, so it's a tiny Shakespeare data set. Okay. Well, the tiny Shakespeare data set there's this manageable size and more efficient architecture. The tiny Shakespeare data set contains 1 million characters. Okay, and we're doing Wharton tokens, I think, right? The character level now GPT is to predict the next character in a sequence, make it simpler and than token-based models. Okay. For a few minutes in a GPU. debugging on modest hardware like a MacBook. Okay. So it's something like Tiny Shakespeare. Okay. A misunderstanding. Okay. Baby GPT model with 6 layers, 6 dimension heads, embedding dimensions, context length, 10 million parameters, not 100,000. Okay. Okay, then why is this? Then it's probably this probably was misleading. This was probably misleading. But anyway, let's try to just keep it that small. Let's try to keep it that small, see what happens. Then we can dial this up, so that's fine. Like, but it's good to know these. Vocabulary size. So only 65 unique characters. Okay. Okay. Interesting. All right. Again, we're learning. So we're here to learn those first principles, those basics of like how are these things debugged and what are the things that you're tweaking and looking at, right? Because we just need the practice. We're practicing. So write the script. Okay. Okay, so still working on it. And then I'm probably gonna, at this point, I think I'm gonna ask it to clean up a bit, because this is very messy. I want this to be easy to work with. Okay, so I'm gonna ask it to clean up a bit. I want to do some cleanup and have a simpler project structure. Here are my requirements. I'm trying to have a playground where I can test different model configurations. I want to be able to quickly start a training run on a specific config and have the loss results stored, generate it and store it, and stored. So I'd like to so I'd like to basically, what else? I'd like to have essentially, so I'd like to have different model configurations, parameter sizes, etc. I'd like to have 2 tools, a tool to experiment with different init techniques, a tool to experiment, a tool to debug tool to debug the what are we trying to debug? Tool to debug backpropagation. Those don't need to be big tools. Just use whatever is in the workspace, if possible. And then keep the vocab encoding part. Keep the vocabulary the vocab encoding part as is. Let's see what it does. Okay, so it's just because it's grown to be too messy, and yeah, but that's what else, because essentially that's what we want to do, right? That's what we want to have. We kind of want to have, we want to have the possibility to experiment with these, right? That's how I would approach designing one of these things. Basically, take a data set, you know, you kind of have a data set, you have a data set, you build, so you kind of custom build an architecture that you want to work with and test with, and then you want to do well, maybe I went too far by just calling it tools, because now he's gonna build like a full-fledged tool set for these. Yeah, so you want to be able to test the different initialization techniques. You want to be able to test whether backpropagation is being done correctly, and keep in mind, I want to be able to test all these things in a modest CPU setup. Your average MacBook. So that's an important thing. Cool. Perfect. In the meantime, what I want to check is multiple things. I want to go and check these. I want to go and do Grok. Can you give me a surface level comparison of different LLM frameworks and tools like PyTorch, basically TinyGrad and such, and what are their features and how do they compare to each other? Do some good research on these. We're super grokking, so. And then we're letting this guy here work. That probably will take a while. Because obviously then at some point I'll just pick one of these and kind of, I think this will help me go a little faster, different things. But I wanna definitely test without the tools and without the frameworks. I wanna practice without these things, right? It's the most important stuff. So we're slacking a bit. That's a good one. You're late, bro. Yeah, that's the problem with these. I tend to kind of like get distracted while the LLMs are, while the agents are working. Tool, change the backpropagation bank tool for, okay. Let's see what it comes up with. TensorFlow, JAX, TinyGrad. It almost feels like I'm so far behind all this stuff. I'm so far behind all this stuff, like, because people like, it's this, the amount of tools, models, platforms, and things that have developed in the past couple of years is insane. So you can host models in here. Deployment and inference providers. Fuck, man, that's so crazy. This is so crazy. So chat completion, feature text to image, text to video, file AI is so crazy. Bro. Free demo for spaces. So what is that? 0 GPU and dev mode for spaces. Free credit across all inference providers. $9 a month. Seems quite a steal, to be honest. Space hardware inference endpoints. In a way, I'm kind of like loving that. I have the feeling that all the stuff is going much more like pay to play than things used to be online. Okay, see where we are. We got something or not? Yeah, we got something here. Okay, cool. So the thing is, I never know where to start reading because I don't want to read the whole thing. You ask it to research and then you don't want to read the whole thing. So research is the best. Research the flexibility, transfer access to production. High performance TPUs, starting out being simpler and hardware extensible, but less mature for LLMs. Yeah. Okay. Research and prototyping, dynamic computation graph, system cooling. Well, I guess the advantage of these things is they basically remove all that uncertainty of like, am I doing the right thing in terms of the back propagation, and everything that is in there is just kind of, it comes in automatically by these libraries. It's solved by these comparison summary, each framework, research. Okay. I didn't know it was developed by Facebook AI. Okay. Very Pythonic. It's good. TensorFlow. More flexibility, physical and production readiness. Okay. And then JAX is by Google. High performance. Why would Google do JAX and also TensorFlow? What's the difference? Okay, those are things for like the big boys, I guess, already. TPU support, like the fancier things. Okay. TinyGrad is a lightweight, emerging deep environment maintained by TinyCorp. Simplicity and extensibility. I'm almost thinking like this is probably the best one for learning, actually. And I'm very, very tempted to just go and say TinyGrad. GitHub. I think TinyGrad is open source, right? Fuck, is that a NAT? No, no, that's a link. Sorry. Okay. TinyGrad. So we'll look at both. We'll look at micrograd and we'll look at TinyGrad. And I want to understand everything. I wanna look at the code. Okay, so definitely we'll do these micrograd and time. That's what we're gonna do next after we're done with these, right? So what do we have? Okay, so we have tools requested. Okay, model playground, a simple clean interface for testing for model configurations to configure models from tiny to large sizes, route visualization, save results for comparison, init explorer, backprop debugger. Efficiently on more CPUs. Okay, so how are these tools to be used? Please delete all the files that are not needed to run these tools in the training. Okay, so we have run with small model version. Okay, model playground config small. Init Xavier epox 3. Okay. Okay, so basically the playground stuff is just what then runs the training, I guess. This is what, I mean, yeah, let's see how that works actually. Let's just play with these tools. Python debugger, backprop debugger, compare flow, mode flow, what is that? Gradient flow during training. Okay, track gradient flow during training. Okay, so I'll let it continue, and I'm gonna stop for now. I first want to kind of mature these tools just for my own usage. Just, you know, we're learning without a framework, and then we'll dive into, later on we'll probably do tinygrad, micrograd, and my goal is, after playing with these for a few days, I'll eventually move to diffusion models as well, because I want to learn about those as well. Cool, bye-bye.